In this video, I just want to go through two quick examples of how we're factoring quadratic trinomials. The little X that I draw to organize my process is it's just my way of doing this. Do not feel any pressure to use that. Okay. So no matter what type of polynomial you start with, the first step is always to look for a GCF, a greatest common factor. So when I look through these three terms, I can see that all three terms contain a 3, right? 3 can go into each of those three. So I'm going to factor that out, which feels like you're undistributing. If you had to describe what we mean by factor out a GCF, it's undistribute. So I'm saying 3 times something is 3x squared. Well, 3 times x squared. 3 times something is negative 9x. That would be negative 3x. 3 times something is negative 12. Find negative 4. Okay. Now, once you either remove your GCF, or if you look but don't have one, don't find a GCF, the second step is based on how many terms are in the remaining polynomial. Since what I'm looking at here in the parentheses has 3 terms, it's still a trinomial, I'm going to try this little process with the magic X. Okay, now to go through those steps, I need to first identify the A, the B, and the C in the quadratic polynomial. So what we mean by that is we think of standard form as, that's an A, ax squared plus bx plus c. Well, for the example we're looking at here, what's left in these parentheses, we don't see any coefficient in front of the x squared, which means it's a 1. So our A is 1. Our B is whatever's in front of the x to the first. So B is negative 3. And the C term is the constant, that's negative 4. Okay. Now, for trying to choose the appropriate factors, I say I just set them up in this little X, but that's optional. You don't have to do that. You don't have to use it. You don't have to show it. Okay. So I take those A, B, and C values that I just found, and I want to multiply A times C in order to decide what product am I looking for in my factors. Product meaning the answer to the multiplication problem. So A is 1 times C negative 4. That means I'm looking for a product of negative 4. And the desired sum, when I find my factors, I want them to add up to whatever the B term is. So my desired sum comes from B, which in this case is a negative 3. Now, what I'm doing here is just planning ahead. I need to look for two factors, two numbers, that if I multiply them together, it's negative 4. While adding them, I end up with negative 3. Right? Well, we can kind of start off by saying if you're going to multiply and get a negative product here, negative 4, I need to have two different signs, one positive number, one negative number. Now, the ways we know to multiply and get 4 would be 1 times 4 or 2 times 2. So which set of factors there, if I make one positive and one negative, could I put together to get negative 3? Right? And that would, of course, be the 1 and the 4. Right? Which one should be positive or negative is based on whether you want that sum to be positive or negative. Since I want a negative 3, that means I want to add together positive 1 and negative 4. Right? By choosing these, I'm saying I know they will multiply to give me the negative 4 at the same time they are added to give me the negative 3. Okay. Now, once I have those two factors, I come back over here to my my in process, factoring, and go, I still have a 3 sitting in the front. I can't lose that. It's still part of the factored form. But I'm going to split the trinomial that's up here into two binomials, right, whose product is x squared minus 3x minus 4. Right? Now, part of those come from the two factors I just found. So I'm going to use plus 1 in one of the parentheses and minus 4. It does not matter which one goes in which parentheses. Now, I'm going to temporarily fill in the front part here by using the a value. And I need to, since I'll be multiplying these together, or in theory I could multiply these together to get x squared, then I need 1x and 1x. Right? I don't use the entire x squared because if we were to then multiply this back together, x squared times x squared would become x to the 4th, which is not what's in our original polynomial. Right? Now, sometimes, many times, at this step right here, the factors don't actually work. Right? I call them wacky factors because it's a part of the process that we need to perform, but they wouldn't actually, if you stopped right now and checked your work, it wouldn't give you back the desired trinomial. What we have to look for, this one last step, is decide, is there a GCF in either or both parentheses that I can divide back out of there? So I look at 1x plus 1. There's not really a GCF in there. 1 can go into everything, so we don't count that. So there's nothing I should divide those by. Same goes for 1x minus 4. There's no number that we would say goes into both of those other than 1. So my final answer is just what I'm looking at. It's 3 times the quantities x plus 1 times x minus 4. Okay. Now I'm going to flip over to the next page and do one more where I will have to do that extra step where at this step here in the process, the factors won't actually multiply back together to produce what I started with. I will have to divide out a GCF. Okay. So if we took a look at this one, our first step again, of course, is to look for a GCF for all three terms, the greatest common factor. I don't have one. There's no number or variable that can be removed from those three terms. So I move right on past that step and go, okay, it's time to try this magic X, if you will. So again, for the product that I'm looking for, I'm multiplying A. Well, I guess I should pick these out. The A value here is 6. The B value is negative 13. And the C is negative 5. Okay. So when I'm setting up my X here, A times C gives me negative 30 for the product I'm seeking. And the sum comes, again, just from the B value, negative 13. So again, I'll start with my signs. If I want a negative product, I need one of each. I'll need a positive and a negative. And then I'm thinking through all the ways I might get 30. So 1 times 30, 2 times 15, 3 times 10, or 5 times 6. Now, at a glance, it appears 2 of those could be put together to get 13. In fact, you might even lean towards the 3 and the 10. But keeping in mind that the factors have to have different signs, a positive and a negative, I'm going to end up actually using 2 and 15. All right, because 3 and 10 have a difference of 7. 2 and 15 have the difference of 13. All right. I'm going to want the smaller value to be positive and the larger one negative, so that when I add them, I do end up with negative 13. Okay, so we return over here. Again, there was no GCF originally, so I'm jumping right to these wacky factors that may or may not work. And again, I take, since this is 6x squared as my first term, I'm going to put 6x in the beginning of both of those. And then the second part of each one comes from the factors I just found in the x, plus 2 and minus 15. Now at this step, if I were to try to check, if I were to FOIL or distribute this back together, it would not equal 6x squared minus 13x minus 5 because I'm not done. Right? This last remaining step, which we did not need to perform last problem, was I have to look, what can I divide both of these values by? So 6x and 2, I can divide both of those by a 2. So this first factor, this first binomial, turns into 3x plus 1. In the second set of parentheses, my second factor, I look at 6x and negative 15, and I could actually divide both of those by a 3, leaving me 2x minus 5. Now, if I referred to this step as wacky factors because they weren't accurate at that time, these are my actual factors. And I could check that if I needed to by multiplying it back together. Multiply either, whether you call it FOIL or double distribution, it would look like this. 3x times 2x is 6x squared. The outers, when I multiply 3x times negative 5, is negative 15x. Inners, 1 times 2x is 2x. And 1 times negative 5 is negative 5. If I look here, I find a set of like terms in the middle. So 6x squared minus 13x minus 5. It does match the trinomial that I began with. Hope this helped you.